So we're here at the example table, and in this video we're going to talk about the derivatives of the remaining four trig functions: tangent, cotangent, secant, and cosecant. So just as a reminder, let's take a look at those derivatives. The derivative of tangent x is secant squared x, and the derivative of secant x is secant x times tangent x. Now what about the co-versions, cotangent and cosecant? Well, the derivative of cotangent of x is negative cosecant squared x, and the derivative of cosecant x is negative cosecant x cotangent x. So it looks like a lot to remember, but there are some nice parallels between tangent and cotangent. Tangent goes to secant, cotangent goes to cosecant. Right? The only difference here is this negative. So you got secant squared, negative cosecant squared. Likewise over here there are nice parallels, secant and cosecant. Secant goes to secant tangent, cosecant goes to cosecant cotangent, but again with a negative here. So if you see these patterns, it makes it easier to memorize. So let's look at an example. Suppose f of x is tangent x times secant x. Well, by the product rule, f prime of x is the derivative of the first thing times the second thing. So the derivative of the first is, the derivative of tangent is secant squared. So we get secant squared x times the second part, which is secant x. And then plus the first part times the derivative of the second. So plus tangent x times the derivative of secant, which is secant x tangent x. And we can simplify this a little bit. We have secant squared times secant. So this is secant cubed x, and then tangent secant tangent. So plus secant x times tangent squared x. Now note that you could also have written tangent x times secant as sine x over cosine x times 1 over cosine x, right? Because tangent x is sine over cosine, secant is 1 over cosine, and you end up taking the derivative of sine x over cosine squared. And you'd get the same answer. It might look different from this, but it's going to be the same. So let's look at another example. So now let's say that f of x is x times cotangent x minus cosecant squared x. Then f prime, well, what is f prime? So this first part, we'll need the product rule because we have x times cotangent. So the derivative of x is just 1. So it's 1 times cotangent plus the first part times the derivative of the second part. So this is plus x times the derivative of cotangent, which is negative cosecant squared x. And then minus the derivative of cosecant squared. Here we'll need the power rule and the chain rule. So cosecant squared, a 2 comes down. Let's actually write this on the next line. So minus 2 times cosecant x to the first power, and then by the chain rule times the derivative of cosecant. And the derivative of cosecant is negative cosecant cotangent. So just to simplify a little bit, this is cotangent x minus x cosecant squared x. And then we have minus and then a minus here. So this likewise becomes a plus. So we have plus 2 and then 2 copies of cosecant. So 2 cosecant squared cotangent. Let's do one more example. Here, let's let f of x be secant squared x divided by cosecant squared x plus 1. So we could use, what would we need? We'd need the power rule, the chain rule, and the quotient rule here. But let's see whether we can simplify this a little bit first. This is equal to what? Well, secant is 1 over cosine. So secant squared is 1 over cosine squared of x. Cosecant is 1 over sine. So cosecant squared is 1 over sine squared x plus 1. Now, dividing by 1 over sine squared is the same as multiplying by sine squared. So this is sine squared x over cosine squared x plus 1. But what's sine squared over cosine squared? That is simply tangent squared plus 1. And if you remember your trig identities, tangent squared plus 1 is secant squared. So to take the derivative of this thing, all we need to do is take the derivative of secant squared. So let's do that. So f prime of x is 2 secant x, this is from the power rule, right? The 2 comes down, times secant x times the derivative of secant x, which is secant x times tangent x. So this is 2 secant squared x tangent x. And so there are some more examples of derivatives of trig functions.